Hello, geology class. Welcome back to another day of learning about earthquakes. So here I have a pretty cool simulator that I found. It's an earthquake simulator. I'm going to go and press play here, and it's going to start an earthquake. So we've been learning a lot about earthquakes so far. There's good reason for that. Um, so we're going to start looking at some applications of what we can use earthquakes to figure out. And so in this application here, notice that the P waves are ahead of the S waves, which are ahead of the surface waves. And that's kind of what you've been learning about. P waves are faster than S waves, and the surface waves are even slower than that. This simulation is pretty complicated, which I'm not going to include it as a part of an assignment. You can see here on the left that different earthquake stations are registering these waves. There's different stations marked on this map here. I'll leave the link to the simulation in case you want to play with it. But the real cool thing about the simulation is I can turn the globe around to see the inside of the Earth. And there's some weird interaction that's going on here. So let me start the simulation from scratch. Can I pause it? So here, remember the P waves are the first earthquake waves to come out of an earthquake, quickly followed by the S waves. So P waves are compressional, which means that they can travel through liquid. S waves are transverse, which means they cannot travel through liquid. That's important because not all of the Earth is liquid. Or sorry, not all of the Earth is solid. Some of it is liquid. You see these blue S waves cannot penetrate the outer core. Now, so today we're going to talk about the structure of the Earth. And the reason that we know anything about the structure of the Earth, I'm going to pause it here, is because of earthquakes and earthquake stations. Just like yesterday's video, you saw how seismologists can pinpoint where earthquakes begin due to having multiple earthquake stations. Well, having multiple earthquake stations around the world allows us to study the structure of inside the Earth. Earthquakes can travel for long, long ways, and they can travel all the way to the center of the Earth. When scientists realized that P waves can travel through any material, solid or liquid, but S waves can only travel through solids, and then they found out that S waves could not pass through what's called the outer core, they realized that, hey, uh, the Earth has a liquid and solid core. You're going to learn more about that today as we learn about the structure of the Earth. So far while we're learning about tectonic plates, we learned about the crust and the mantle. Now we're going to dive a little bit deeper and start to look about the inner and the outer core. So it's all thanks to earthquakes that we know anything about the inside of the Earth, because mankind has only managed to drill down halfway through the crust. And as you look at this map here, you can't even see the crust because the crust is such a thin layer. It's not really worth mapping. And we haven't even drilled halfway through the crust. We haven't reached the mantle. It's too hot to get down to the mantle. So you'll be learning about more techniques about earthquakes today, and you'll be learning about the structure of the Earth. And I'll leave this link to this simulation in case you want to play around with it. Look at how the waves bounce around on the inside of the Earth. And really, even as I look at it, it's too complicated for me. But hope you enjoyed this unit about earthquakes. And who knows, maybe this has encouraged some of you guys to pursue a career in this area. Lots of people besides geologists use earthquakes in their studies. Even like one of my former community college teachers was an oil surveyor, and so he would have to understand how seismology works just to survey potential drilling sites for oil. But anyway, if you have any questions about today's work, please let me know, and have fun with all of the material. Talk to you later. Bye.